Hello and a warm welcome to our webinar about digital warehousing. My name is Kerstin and I'm the moderator of today's webinar. Here with me are my colleagues Christian and Sammy. Christian is part of the Forward AM team, so BASF's additive manufacturing business. And Sammy is the co-founder of Replique, an online platform enabling a decentralized production of spare parts. In the following presentation, Christian and Sammy will guide you through the concept of digital warehousing and will support you in setting up the ideal infrastructure to benefit from 3D printed spare parts and the digital warehousing concept. And now let's dive right in. Christian and Sammy, please introduce yourselves.
So thanks, Kerstin. Hi, everyone. My name is Christian Reinhardt, and I'm a business development manager at Forward AM. I'm already with BASF since 2019, but I'm working in the additive manufacturing industry since 2016. Sammy, could you please also introduce yourself?
Sure. My name is Kumar Samanvay. Short name to remember easily is Sammy. I have a bachelor's in engineering and master's in business administration. I joined BASF in 2018 and co-founded Replique as a part of BASF's incubator in 2019. I'm working with startups since 2013.
Okay, perfect. Thanks, Sammy. So today, we have actually structured our webinar around one specific use case. So let's try to imagine that you are the head of an after-sales department of an OEM manufacturing cranes for construction. Already decades ago, your company has manufactured a small special series of cranes to renovate, for example, churches. The doors of the cab of the crane open and close automatically. In the doors, for the opening and closing mechanism are small plastic gears. Because of space limitations, these gears were back in the days a custom construction and a custom product. After 30 years, the supplier of these gears discontinued its production. If there is a problem with the door, and especially with the door mechanism, the crane cannot be used anymore. The impact of the downtime of a crane is huge because then if the crane is not working anymore, the whole construction site is dependent on that. And even if you think that, okay, a door of a crane is a quite small segment, yeah, but because of safety issues or safety reasons, it's forbidden to use the crane anymore. Additionally to that, that not only the part is not available anymore, also design of this part is not available anymore. So yeah, let's check out what our options can be. So traditionally, for such a part, you would consider injection molding to remanufacture it. So first of all, you would have to invest in a new tool. Producing a tool costs cost, and it takes quite some time. If you want to source this part externally, in most of the cases, this also comes along with a quite high minimum order quantity. So the revenue also for the service provider of injection molded parts must be worth equipping the machine. After the parts were produced, you must store them somewhere. So the higher the minimum order quantity is, the more parts you would have to store somewhere. And if you also have invested in a new tool, after the parts are manufactured, you also have to store them somewhere. So you have a lot of inventory what you have to manage. And then considering where your injection molding service provider is located, it can be, for example, China, because there you get low prices for injection molded parts. But then you also need to ship these parts around the globe, and this can cause high cost if you need to do it by plane or air freight, or this can take ages if the parts come over by ship. And so it would take quite long until you have the parts available at your construction site. So considering these points, we want to show why 3D printing can be a game changer and why it would be worth to also consider 3D printing for such spare parts. So let's have a look which steps affect the total cost per part. We start from the very first beginning, so logistics and purchasing. The standard process is request a part at different suppliers. Then you negotiate the minimum order quantity, you negotiate, of course, the prices, and you negotiate the shipping time or the availability of the part. It's in 3D printing, it's more or less click and order. You just need the 3D files, upload it somewhere, and you can order the part directly. It can be the case that a redesign or reverse engineering is necessary if you don't have the parts, but this is the case for 3D printing, but additionally also for injection molding. But in 3D printing, you would only have to redesign the part. In injection molding, additionally to the part itself, you would also have to redesign the tool. So last fixed costs in our scenario are the production setup cost. So setting up a 3D printer is quite easy. Just equip it with the right material and then upload the file and go for it. And equipping an injection molding machine is way more afforded. After setting everything up and starting with the production, we come to the variable costs. For injection molding, because in most cases it's mass production, the variable costs are quite low, especially when you compare it to 3D printing. So the material is in most cases cheaper, the production is faster, and the outcome or the volume of outcome is also higher, which decreases the price per part. After the production run is finished, the tool and the manufactured parts must be stored in the warehouse, which generates then, if you have to store them physically, generates then inventory cost. The printer can be directly used to print other parts. So to summarize this slide here, 3D printing is cost efficient if a low volume production is needed, if logistics and inventory costs are huge, and if there are high costs of reordering and retooling. So now we have shown, or I guess that we have shown, that 3D printing can be an option to manufacture spare parts. But also for 3D printing, some kind of infrastructure is necessary. Now we come to the part of the webinar where we want to show how we as BASF can offer an end-to-end solution in implementing 3D printed spare parts, and to make it especially as easy and as secure as possible. So we as BASF Forward AM have access to all kind of BASF raw materials, and additionally to that, we also have access to the research expertise at BASF to make unique and also special 3D printable materials or 3D printable material formulations out of it. Here we offer materials for the most common polymer 3D printing technologies. But additionally to that, maybe you have also seen it, we have a metal filament, so that you also could quite easily manufacture stainless steel parts. Additionally, or supportive to our materials, we offer a quite wide range of services, like virtual engineering or part simulation, to really prove that the 3D printed parts perform as expected. Or we also offer special coatings for flexible materials, and to really support the business cases or the implementation of 3D printing. And now is the perfect timing to hand over to Sami to explain about Replique and their offerings.
Thanks, Christian. So as Christian mentioned, BASF considers 3D printing as a very important domain to be active in. And that's why it's continuously building solutions to serve customers with different personas. We recently realized that the 3D printing services and formulations play a very important role, and we can further augment this with the help of digital manufacturing, distributed manufacturing, and digital warehousing. So what does distributed manufacturing mean? With the help of distributed manufacturing, Replique tries to bring in a global network of secure print farm, and this gives the OEMs a freedom to print anywhere in the world with the designs that they have developed or co-developed with 3D printing solutions or Forward AM. The digital warehouse solution is again an online platform which enables the OEMs with on-demand printing. As Christian mentioned in the previous slides, it helps them to reduce their total cost of ownership by reducing their tooling cost, by reducing their MOQs, and of course the inventory. Because you print on demand, you have less inventory to store in your physical inventory. So how does this actually work? That's a very good question. Let's look at the next slide to get into the details. Well, actually, it's a very simple process, as simple as 1, 2, and 3. So step 1, we do a workshop where the BSF experts get together and try to understand your status quo. The next step is we go into the part requirements to understand what is the usage of this part, how can we further optimize these designs, and what changes need to be implemented. Once this is done, your final design is ready. And then you're up to join the digital warehousing workflow. And then your next question would be, but what is the digital warehousing workflow? So I take the help of laser pointer. We start from here. This is the easiest place to start with. As an OEM, all you need to do is to first bring in the designs. Now, it is quite possible that you are at different stage of your 3D printing adoption, and you might need support to convert some of your already existing designs or re-optimize those designs, or maybe fine-tune those designs for an optimum outcome in 3D printing. And that's where the BSF services and support come into the picture. Once you take the support of these services, your design is actually made available for 3D printing for a given material using a given 3D printing technology. This file is then stored onto Replique's secure digital warehouse. Now, then this secure warehouse is connected to an sales channel. This could be the OEM's e-commerce channel, or if required, we can also help set up an online store for the OEM. The store has designs, and these designs are then made available to the end customers. So basically, this is where the customer finds the design, places the order. As soon as the order is placed, this order is received by Replique's digital warehouse, which then encrypts this file and securely transfers this to a trusted print farm. The print farm has a small piece of software running, and they can decrypt this file to understand which design is this, print this, and send this to the customer. What is really important to understand over here is that with this encrypted file, the OEM can decide how many printouts do they want to make a print farm eligible to print. For example, an OEM can enforce that this file cannot be printed by more than X number of copies in a day. They can also put a rule where they can say this design can only be printed with this particular material. To make it even more secure, they can even say they can only print this with this particular printer manufacturer. So this is what the encryption does. It basically helps in protecting the IP of the OEMs. And once this transaction is complete, the OEM gets a part of the revenue which is generated in this transaction as well. So this is one of the few approaches where OEM joins forces in order to enhance the experience of their customer. So what are we doing in a nutshell? So let's assume this is the cost of the equipment. When we go out and we purchase a crane, let's say it's cost 50,000 euros. Over a period of time, the cost of this equipment decreases. And of course, over a period of time, the cost of the maintenance of this equipment increases. The point at which these two curves meet is actually the point of the optimal life of the equipment, which means that beyond this point, the cost associated with the equipment would be higher than the actual cost of the equipment if I have to sell this in the market. And for a lot of consumers, this is a good time to also sell the equipment. What Replique does is that by making the spare parts even more readily available, it pushes this optimal lifetime of the equipment by a few years, and thus making the equipment the spare parts of the equipment more available, and making the experience of the customer even more joyful to use this equipment for a longer period. This is the benefit that Replique brings to the end customer directly, but for the OEM, this also means an improved total cost of ownership. They can strengthen their brand value because they have now more happy customers who trust their brand. With the global reach and the help of a global 3D print farm network, um, the OEMs can print the spare parts anywhere in the world. And of course, like I explained in my previous slide, they can make extra revenue stream by selling these spare parts or the digital license of these spare parts. Here's a short cost comparison coming back to the use case that Christian mentioned in the beginning. Let's say for these gears, the yearly demand is around 500 pieces, and you have to do a new tooling. So let's say the injection molding tool itself costs 4,000 euros. Then there's the setup cost, which is an additional 1,000 euros. The design cost, an additional 100. Production cost, of course, goes down drastically because you're mass producing this. And the time until the start of the production is, let's say, 5 months. Now let's compare this directly with 3D printing, which does not have any tooling cost, just a slight fraction of the setup cost, because you need this for setting up the printer parameters. Design cost is almost the same. And yes, there's a higher cost per part, but you're also having a quick turnaround time. Often OEMs that deal with mission critical machines, they prefer time over the actual cost. And we have validated this with our discussion with a lot of OEMs that some of the parts that they want are very, very time critical, which means they would be willing to pay higher amount of money just to get the part in time. What we have also done through our research and observed is there's approximate breakpoint, let's say around 1,000 parts. So 3D printing is definitely a very good solution to opt for if the volume of the part needed per year is less than, let's say, 1,000. But if it is more than 1,000, then of course 3D printing does not make sense, and this is where other technologies also come into the picture. This is a quick overview of Replique's digital inventory. We try to show you how you can onboard your part. So when you onboard your part, you put a title, part number, SAP ID. You can add the 3D models, which you have identified with the BSF experts in the step number 1. You can add the production parameters, which you have identified with them in step number 2. You can have additional attachments if you have some, or you could also make some comments if you want to communicate this information to the print farm that picks up this job. Then there's also a dashboard where you can clearly see how many designs do you have in your digital warehouse, and what is the status of each of those designs, which can be seen over here. And we also give you a quick update of how many parts were printed and how much revenue did you make by having those parts in comparison to the previous time. Then quickly summarizing the benefits of digital warehousing. So for OEMs, BSF offers an end-to-end solution by identifying the right design, storing the design securely, and manufacturing these designs on demand via the online platform. And of course, for print farms, BSF connects with the worldwide network. It also reduces your customer acquisition cost and creates a very nice platform for both parties to interact very securely.
Yeah, thanks for these insights. We're now at the end of this webinar. If you have any further questions, comments, feedback, you can approach our experts directly. Please find Christian's and Stanley's contact details on this slide here. And yeah, there's nothing else to say then thanks again, Christian and Sammy, and of course also you for joining, for watching the webinar. We're happy to stay in contact with you. Talk to you soon, and goodbye.